In this video, we're going to look at the even and odd properties of trig functions. So if you recall, a function is even when if you evaluate the function at the opposite of x, it's equal to evaluating our function at x. And then a function is odd if when you evaluate the function at the opposite of x, it's equal to the opposite of our function when evaluated at x. So when we're looking at even and odd functions, only the cosine and secant are even. Our other four functions are odd. The sine, the tangent, the cosecant, the cotangent, they're all odd functions. And what does that mean? So that means that if I evaluate the cosine at some negative value of theta, then it's the same as if I evaluate cosine at the opposite of theta. So cosine of negative 60 would be the same as the cosine of positive 60. However, with something like the sine of negative 135 is just the opposite of the sine at 135 degrees. So this is helpful in that it can help us kind of just focus on remembering the measures of our trig functions in the positive rotation around the unit circle, and then remembering whether it's even and odd, we can either just take the opposite of that value or keep it the same if they're even. So let's try a couple examples. So we want to find the exact value of the sine of negative 60 degrees. Now, we said that sine is an odd function, so that means that this is going to be the same as the opposite of the sine at positive 60 degrees. And at 60 degrees, the sine has the ordered pair is 1/2 comma rad 3 over 2. And the sine is the y-coordinate. So the sine at 60 degrees is the square root of 3 over 2. And we are taking the opposite of that. So the sine of negative 60 degrees is just negative rad 3 over 2. So that's how we can use the fact that the sine is an odd function to evaluate this. So let's take a look at another example. We want to find the exact value of the cotangent at negative 3 pi over 2. Again, this is another odd function, so that means that it would be the opposite of the cotangent at positive 3 pi over 2. 3 pi over 2 on the unit circle is down here, right? It's down here, and it has ordered pairs of 0, negative 1. And the cotangent's the reciprocal of the tangent. The tangent is y divided by x, so this is going to be the x-coordinate divided by the y-coordinate. So it's the opposite of 0 divided by negative 1, which is really just the opposite of 0 or 0. So the cotangent of negative 3 pi over 2 is equal to 0. Let's look at one more. For this one, we want to find the exact value of the cosine of negative pi. Cosine is one of our even functions. Now, with it being even, that means that the cosine of negative pi should be exactly the same as the cosine of positive pi. So at pi, we know that we have the ordered pair negative 1, 0. Negative 1, 0. It's half of our rotation around the unit circle. And the cosine is the x-coordinate. So the cosine of negative pi is just going to be negative 1, the same as it would be for the cosine at positive pi. And that's how we use the fact that different functions are even and odd to help us evaluate our sine, cosine, tangent of negative angles.